Does the SAT math always require complicated equations? That's a question a lot of my students have that has an easy answer of no. And I'm going to give you 3 questions of one type that shows you how you don't need complicated equations to solve not just easy questions, but also medium level questions. This is probability, category G, level medium. It's where you have to approximate a value and then see which choice fits it best. So we'll do these questions together. If you have questions on them, always leave them in the comments. You'll see you don't need to be crazy with equations to solve some pretty standard SAT questions. The table to the left shows information about a store's color and size options for a certain shirt. Which color shirt makes up about 1/10 of the total number of gray shirts? So you have this chart. On one part there's the red, blue, green, gray, the colors of the shirts, and then we have sizes, extra small, small, medium, and large. So it's asking for 1/10 of the total of gray shirts. So if we look at gray, we have a total of 46. You can trust the numbers here, they're not going to lie there. And then which of these is closest to 1/10? 5 is the closest to 1/10 because 5 out of 46 would equal something just a little north of 1/10. It'd be like 0.109 or something, and everything else would be bigger than that, so they'd be too big. So it'd be 5 out of 46. So you can see I didn't even have to do calculations on a calculator. I just approximated, and I would know that that's medium, so it's C. Okay, so we'll do another one of these types, and then you'll see how you can answer these questions that are common on the SAT. So we have this one here. The table to the left shows information about a store's fresh fruit options. Which type of fruit has about a 0.2 probability of being selected? Okay, so here they don't give us the total, but we can just do that ourselves. That's not too complicated. We'll do 14 plus 11 plus 9 plus 9 plus 13. That'll be 25. And you can just put this into the calculator. Plus 9 is 18, plus 13. And when I say calculator, I mean Desmos. So now we'll do 25 plus 18 plus 13. That's going to be 25 plus 31. Again, you can do this on the calculator, but I'm just doing it here for fun. 56. So we have 56 total. Which of these gives you a 0.2 probability? So that's about a 1/5 probability. We have bananas, 9 over 56. 0.16. Okay, then we have mangoes, 14 out of 56, which I can tell you is exactly 0.25. You could approximate. If you can do it in your head, you would be able to tell that apples should be the best option, but we're going to work it out together here. 0.25. This one's farther than the 0.16, so we'll cross it off. Then we have apples, 11 over 56. And that gives us 0.196, 0.196. So that's now bigger than this one, closer to the 0.2. And we'll do oranges last. So for oranges, we'll do 13 out of 56. And that'll be 0.23. So that's also gone. Our best option is this one, which is apples C. Again, crazy equations, not at all. Simple probability concepts applied to a chart. And that makes it medium level. So I'm going to leave you with this one to do on your own. Let me know what you get in the comments, and it's not too bad at all. It's the same process we were doing, nothing too crazy. The table to the left shows information about a store's color and size options for a certain shirt. Which color shirt makes up 1/4 of the total number of mediums? A, red, B, blue, C, green, D, gray. Try it out. Let me know how it goes for y'all, and I'll talk to y'all soon. Bye.